Okay, let's continue. So any question till now?
Oh, I don't.
Okay, clear. Okay, yeah. So you see this a lot, right, from the MI, okay?
Okay.
So what is ML? Okay, we define LZ. LZ is the subquantity of L. Remember what is L? L, uppercase L equal to square root lowercase l times L plus 1 multiply H bar. Alright? So this is L, and the Z subquantity, the projection on the ZX is what? ML. Okay?
Okay.
Remember what is L? L is square root L times L plus 1. Right? So when L equal to 0, this is 0. If it's 1, then this equal to square root 2 equal to 1 point something. Right? If this is 2 times 3 equal to square root 6 equal to 2 point something. Right? So that's why when L equal to 1, ML can only be 1 because it need to less than 1. When ML equal to 2, then if L equal to 2, this equal to 2 point something, so ML can be 0, 1, 2, 0, 1, 2, and then minus 1, minus 2.
Okay.
So that's why ML equal to 0, positive, negative L, 1, positive, negative L. Right? Okay? So we call this angular quantization. Means in the atom, the direction is not continuous. So this is the angular momentum. You know what is angular momentum? If the electron is rotate, and we define the angular momentum in this direction, we use the right hand. So we call this right hand rule. Okay, right hand rule means if the electron is rotate like this way, and this is the angular momentum. Okay, okay, okay. So L equal to this one. M member is the Z subquantity of L. So this one, okay?
Okay.
So in the space, this is the when the electron is in the XY plane, in the XZ plane. In the XZ plane, then this is the ML equal to 0. In here, this is equal to 1. So here is equal to 2. Okay?
Okay.
So this is, and in fact, this is a cut. So in fact, when ML equal to 0 is this way. ML equal to 1 is this way.
Okay.
ML2 is this way. So if L is here, then means electron is here. L is here, electron is here. L is here, electron is here. That's why the S orbit is
Okay.
sphere, because
Okay.
It's here, here, here. Finally, it becomes a sphere. Okay. Sphere.
Okay.
L equal to 1. Okay? Okay, L equal to 1.
Okay.
So it becomes this kind of shape. Okay, it will be difficult to understand, but yeah, it's three-dimensional. Okay. Okay, so the ML can be 0, means L is here. ML equal to 1 equal to here. ML equal to 2, this is L, this is ML. In the reality, L cannot be here. Why? If L is in this direction, then we don't have delta 0 because L is in this direction. Then our electron will in the xy plane. In xy plane means delta z equal to 0, right? And in this direction means Lz, delta Lz is also 0. If delta Lz equal to 0, delta z also equal to 0, then what happened? But in the uncertainty principle, so this is not correct.
Okay.
Remember, everything need to larger or equal to h bar over 2. But if the L is in this direction, then they are certain. So we are not allowed certain thing. We need uncertain. The nature is uncertain. So it's no good, okay? So for single atom, L can be here, L can be here, L can be here, okay? And they carry no energy, okay? Every single atom, they are in their most comfortable position. At that time, they don't have any potential, okay? However, if we put a magnetic field, MRI will put a radio frequency, right? So in this atom, L is here. This atom, L is here. This atom, L is here. Okay? Because they didn't connect to each other. If I apply a magnetic field, okay? All the atoms, they will align. Because, this is reference. Something like if I'm a soldier, I beep beep, then everybody just alignment, right? Okay? So, original, they don't have energy. But if they go to this direction, they will have a U, right? Different atom will have different energy. If the frequency removed, then they will go back to their original position. Then they will release a signal, right?
Okay.
So this is why you have MI signal, right? Original, all the atom, they have different orientation. After you apply a magnetic field or IF, then they all align together. Then after the IF removed, they will go back to their original position and emit what? Emit an echo. Okay. Hi, I'm here. Hi, I'm here. Okay.
Okay.
And then let's try to calculate how big is the signal or the energy they absorb and they respond.
Okay.
Okay. Before that, let's try to calculate the angle. Okay. This is very easy. If n equal to 3, L equal to 2, ML equal to -1, okay? So what's the angular momentum with the z axis? L equal to 2, ML equal to -1. Is this one? L equal to 2,
Sure.
ML equal to minus 1. Okay, what's the angle? What's the angle to Z? Okay, Z or positive Z or negative A? Okay, positive Z. So I want to get this angle. Okay, how do I get that? Right, this is, what is cosine theta? Cosine theta is, okay, right? This is cosine theta. This is sine theta, right? You know this. What's the definition of cosine theta or sine theta? Okay, so or easier. Let's make it easier. Let's get this angle. Okay, it will be easier. Okay, so what's this? This equal to right L times L plus 1, 2, 3. Okay. And then what's this? This is 1. Okay. For this triangle. For this triangle. This is square root this. This is 1. Okay. So can we get this angle? Sine theta equal to this and this, right? So let's get sine theta. Equal to 1 divided by this is 1 divided by square root 6, right? How do I get theta? Equal to arc sine this, okay? But this is radian, this is not degree, so we need to equal to this divided by pi multiply 180. Okay, so because in degree this is 180 degree, in radian this is pi, so we know pi equal to 180 degree, right? So this is radian, so I divide by pi multiply 180. I convert it into a degree. Okay. After that, we know that this is 24 degree. So which means this is also 24, and this is 90. So 90 plus 24, you become 114. Right? Okay? Easy, right? Oh, easy. Okay. Okay. So remember, okay? Okay. Later. Let's jump to the MRI physics first. Okay. Let's skip this part first. Let's jump to MRI physics first. Okay, so remember, original, the atom have a momentum here. He feel more comfortable, okay, because this is my potential equal to 0. After we have a magnetic field or RF frequency, they will go to this direction. alignment, right?
Mm-hmm.
Alignment. So what's the potential? They rotate from here to here. Okay, so because it's a rotational moment, so we have tau. Tau is something we call it torque. Do not torque. Torque is mu b sine theta. If I have a magnetic dipole means I have some circuit or whatever carry the moment magnetic. We call it magnetic dipole, right? If I have magnetic dipole inside a magnetic field, the tau equal to mu b sine theta. Okay, because this equal to mu cos b, right? Mu cos b equal to mu b sine theta. Okay, so this is from the EN. Okay, and what is u? U equal to tau d theta. Integrate. If I have a linear motion, the energy potential equal to what? Force times displacement, right? If it's a linear motion, but this is the rotational motion, so we can use torque to replace F, using the theta to replace the displacement. Okay, remember what is tau? Tau is mu b sine theta. Okay, we from this location to this location, so this is the potential. Okay, so what's the integration of the sine theta? It's the cosine theta. Right? So this means when I have an atom inside a magnetic field, this is the potential E will get. Okay? Remember what is L? L is mvr. M is the mass, v is the velocity, mv is momentum. Multiply radius will become angular momentum. Okay? And we know what is n, what is r, but what is v? Go back to very beginning. Very beginning. Okay. Okay, anyway. So, what is V? V equal to what? V equal to frequency multiply the period, right? And what else? Okay, because frequency omega equal to 2 pi f. Anyway, just assume that V equal to 2 pi f r. Okay? And what is mu? What is mu? What is magnetic dipole? If I have a circuit, the magnetic dipole equal to IA. I is current, A is the area. Okay? And what is A? A is pi r squared. Okay?
Okay.
I equal to dt dq. Okay? Or equal to qv, because dt ds is v. So we know that what is frequency? Frequency is 1 over time, right? So EF is the current. Okay, so mu equal to this, and L equal to this, and we know that mu will equal to E divided by 2mL. Okay, we make this. And then finally, if we put this inside here, okay, we can get the magnetic potential equal to E divided by 2mL B cosine theta, okay, and equal to, what is cosine theta? Remember, cosine theta equal to mL divided by L. Cosine theta is mL divided by L, right? So cosine theta equal to mL divided by L, or L cosine theta equal to mL. L cosine theta equal to mL, right? mL equal to, the radius is L. Sorry, cosine theta equal to mL divided by L. So L cosine theta equal to mL. L cosine theta equal to mL. Okay? So this is the potential an atom will get inside a magnetic field. This number B is the applied magnetic field. Okay? mL equal to 0, 1, 2, right? And this is a constant. Remember, E is a constant. 1.602 times 10 to the minus 19. H bar is a constant. 6 point something times 10 to the minus 34 divided by 2 pi. 2 is a constant. N is the mass of electron. So this is a constant. This is a constant. We call it mu B equal to Bohr magneton. Okay, so in your NR physics, you use this number a lot. This is for electron momentum. Okay, yeah, but later you'll find out this is not a number you use, because this is the momentum for electron. But in your NR physics, you observe not the electron, you observe the proton, right? So in proton, this will be the mass of proton. So remember, this is the number, this is for electron. For electron, 10 to the minus 5. So in much later, we have proton. Okay, for proton, this is minus 8. For electron, this is minus 5. For electron, it's much larger than proton. And why in NRI you are looking for proton, you are not looking for electron? The problem is in our atom or molecule. Mostly, the electron, they are paired, right? So usually in the atom or molecule, they have their valence orbit are full occupied, which means all the electrons, they are in pair. They are in pair. So if you are in pair, the magnetic dipole, they will cancel each other. So although this number is much larger than proton one, about 2,000 times higher, but because they all pair up, so you cannot measure it, or you cannot observe it. Even in the atom, they are also paired for neutron and the proton. The only one not paired is what? Is proton, because proton has only one proton and no neutron. So in hydrogen, you can see there are only one dipole. So that's why you in MRI you look at the proton. although proton is about 2,000 times lower than this number, but you still look at the proton. Or iron, because iron you have 3 protons, so it's very big, right? So we can put iron as the contrast agent because they have 3 dipoles, not pair up, right? Very strong. So, however, in MRI, sometimes we can still look at electron. Where is there something in our body or water which is have only 1 electron, single number electron, no full field, even number electron, which is radical. You know what is radical? Radical, something like H dot. We know H plus we have no electron, so no dipole. But H dot we have 1 nucleus and 1 electron. I have 1 electron, so if I put radical in our MR machine, I can also get very strong. But they need to use different frequency. Okay, very special. So there are some very special MRI called radical MRI. Okay, radical MRI. Okay. So we can use the DMP to do the radical MRI. Okay. Okay. So how many time we have? 20 minutes. Okay, then we will explain a little bit what is the Schrödinger equation. Okay, so what is fine structure? Fine structure means original, they have some energy level, but when we apply a magnetic field, the spectral light will split. And now we understand, because we know that when we apply the magnetic field, we will increase or decrease the energy for the electron. So then, without the magnetic field, they have only 1 spectral light. When we add the magnetic field, they have 1, 2 more spectral line. We call it fine structure. So Bohr model cannot explain why we have fine structure. In the Schrödinger equation, we can explain why we have this fine structure. This is very easy for you, right? Because this is the same as the NR physics. Okay?
Okay.
So without magnetic field, we have only 1 spectral line. With magnetic field, we have 3 lines. This is fine structure. So Bohr model cannot explain fine structure, but Schrödinger equation can explain fine structure. Okay? And also, what's the probability density? You know, right now, what's the difference between the Schrödinger equation and the Bohr model? First, Bohr model say we have some orbit, right? N equal to 1, but in the Schrödinger equation, there is no orbit. There's no circular orbit. It's just a probability. Okay, the electron can be anywhere. Okay, you cannot find there are theta or phi, only probabilities. They are sometimes here, sometimes there. But how can we find the probability? Also, because this is a time-independent equation, no time, which means electron is not moving. They are jumping. Jumping means the movement is discontinuous. So you cannot take a differential or whatever. They are just keep jumping. Okay? So we will define electron probability density. Electron probability density will be proportional to psi squared. Remember, psi is the imaginary number. So when we talk about I, we have a real number and we have an imaginary number. Imaginary means it's not real. So we can measure real number, but we cannot measure the imaginary number. So if we want to measure electron, we need to convert the imaginary number to a real number. And how? We need to multiply imaginary number to its conjugation. Conjugation means if one number is A plus BI, then this is real number. Then its conjugation is A minus BI. If I multiply A plus BI and A minus BI, it becomes A squared. This is equal to B squared multiply I and minus I. I is minus 1. Minus 1 equal to 1. So this becomes, and this is ABI minus ABI cancel out will become A squared plus B squared. This is a real number. Okay, so in order to measure the imaginary number, we need to convert it into a real number first. So how do I convert it? I need to take the number and its conjugation. Okay, so this is A2 EIN phi, E minus IN phi, cancel out, it becomes A squared. Okay, this is the probability density. Okay, so we need to get what is probability density. It's R squared, theta squared, phi squared. Okay, everything need to be squared. Okay. So if we plot this, then this is R, okay, and this is 1s, 2s, 2p, 3s, 3p, 3d. That's why we can plot this kind of. Okay, that's because we solve the probability density function. Okay, so let's try to regenerate this. Before we regenerate, this is the 1s orbit. Okay, so 1s electron, they can be infinity far away, but the probability is 0, almost 0. Okay, but if the distance becomes small, the probability will become higher and higher. Where is the highest point, or what's the position we can find 1s electron most? You will become A naught. So we know what is A naught mean. 0.53 angstrom. It didn't mean that 1s electron is in 0.53 angstrom. That's because they can be infinity far away or very close. But the most popular position is in 0.53 angstrom. So this is what A naught means. Remember where is our n equal to 2? N equal to 2 should be somewhere, I don't know, here or here. I don't know. In fact, this is the 2s electron. It can be also very close. Also, A naught, and then find A naught, and okay, this is a 2s orbit. Okay, at 2p orbits. Okay, so let's try to regenerate this. Okay. We have 11 minutes. We may not be able to finish it, but let's try to plot this one and this one. Okay, so sometimes if some equation is very, very complicated, I will use Excel to do it. Okay, so this is radius. That's in the unit of A naught. Okay, so this 0.1, 0.2, equal to this plus 0.1. Okay, I try to regenerate. Okay, and what is the R function? R function equal to what? Let's use 1, 0, 0, 1s orbit. Okay, R function equal to what? Equal to R function equal to R function equal to this one, right? 2 divided by A naught 3 over 2. Okay, exponential minus R A naught. In our case, A naught will equal to 1, right? Because I use the unit 1 A naught. Okay, so let's just rewrite this. Two divided by 1 exponential minus R, easier. Okay, or let's just use Angstrom. Let's use Angstrom. So this will become okay. Okay. So what is R? R equal to 2 divided by 0.53, right? And to 1.5, right? And then multiply exponential what? Exponential minus R, this is R, divided by, okay, so this is the R function, okay? R function. So let's try to yeah, okay. So I just put the formula in, and I try to regenerate this, right? R function 1s, 1 is something look at this way, right? You can try 2s, 2p, 3s, just put the equation in. Okay. So I generate this. Right? But this is R. R is meaningless because what we need is not R. We need what? We need this one. Probability equal to R squared dr times 4 pi. Okay? So means what is R squared? R squared is the function square. Okay. So R2 times 4 pi. Okay. So what we need to plot is R squared multiply 4 pi. Okay. So equal to R. Let's make this lowercase r equal to this square times this square times 4 times pi. Okay. So let's try to plot this. Okay, so can we get this? Alright. So this figure is just like this figure, right? So the maxima is A naught, right? What is A naught? A naught is 0.53 angstrom, right? So where is in maximize? Maximize in here. Okay?
0.5.
0.5, right? Yeah, okay. Let me make it more accurate. Okay. Okay, so maxima around here. Right? This is maxima, right? So, okay, so you don't need to do hand calculation. You can use the Excel to help you, right? Okay. So how do I do that? Remember, this is R, alright? This is R squared multiplied 4 pi, alright? Okay, what else? Let's do an example, okay? Can I find, this means the expectation value, means mean value. Okay, so you can try to do this by yourself. But I just want to try Excel. Okay. More. R squared multiply 4 pi. How if I don't multiply 4 pi? Okay, so this is r, right? This is r squared, okay? And I multiply this to 0.01. What is 0.01? 0.01 is dr, because this minus this is 0.01, this minus 1 is 0.01, right? So if I sum it up, it becomes 1. What's 1 meaning? 1 means in the whole space. In the whole space, how many electrons I can find? 1. Right? Okay, so integration all the space. Okay? So if I want to get the mean value of 1 over r, then I need to multiply this to r, 1 over r, okay? Let's use T2, okay? Okay, so this means integration. Sum it up, this is integration. 1.8865, right? So if I do the integration, the result need to be 1 over A naught. What is A naught? A naught is 1 equal to 1 divided by, yeah, this is also 1.88 something, right? This is 1.88 something, okay? Means, yeah, if I want to get this, okay, if I want to get the 1 over r mean value, which means I need to 1 over r multiply this function, and the integration will become 1 divided by A naught. This will be from Excel. I don't need to do the calculation. I just use Excel. I can get the same. Okay, I know you need to go to seminar now. Okay, so let's stop here. Okay, think about it. Okay, and anyway, we'll review it again. Okay, any questions?
I think I need to think carefully.
Just not think. Just do it by your hand. Okay, try to do it by hand job. Okay. Okay, see you.
Yeah, thank you, Professor.